Yes, yes.
I know.
Roman stuff keeps me working. Io faccio la scelta della sessione e lei fa give it a minute and then we'll come
I'm just giving an overview of my.
Filing in, so
Yeah. Give it one more minute and then we're going to start. Do you want to start with a couple of announcements?
Good morning, everybody. I'm Annalisa Calamida, scientist here at Space Telescope and part of the LOC of the conference. I have a couple of announcements for you. One is tonight, as soon as the conference talks are over, we will have what we call SDAS beer event. It's something that happens almost every Wednesday year at Space Telescope. Actually, it's been happening for probably 30 years. And today, it will be free for everybody. There will be beer, cider, sodas, and snacks. So we would like you to join, and other people from Space Telescope will also join, so you can meet some of the scientists and astronomers here. Another announcement is tomorrow night, we will have what we call Astronomy on Tap. And this time, Astronomy on Tap in Baltimore will be thinking about the Roman Empire. So 3 astronomers from this conference will give 3 talks. And this will happen at 7 p.m. at Guilford Brewery. So please come. There will be public buses to reach the place, so you can Uber there. We will give you more information tomorrow how to reach the venue. Okay, thank you.
Okay, so we're gonna start this morning session. I'm gonna be shepherding you throughout the morning. And we're gonna start with Christy, who is the mission head, or my mission head here at the Institute, who's gonna introduce.
Thanks, Gisela. Welcome, everyone, this morning to the Roman Starter Kit Mini Workshop. I'm Kristen McQuinn. I am mission head here at the Institute in charge of the Science Operations Center. This, as we all know, launch is rapidly approaching. In a little over a year, the Roman Observatory will be sent about 1 million miles from Earth to start taking observations. We feel that viscerally here at the Space Telescope Science Institute. The teams that are working really hard to develop the Science Operations Center to support the community. There's a lot of energy and momentum, and it really does feel like we are barreling to launch at breakneck speeds. And this week, hearing the breadth of science and the amount of thinking and dedication that you all have put towards Roman has been really inspiring. The energy and momentum of you is palpable. And it really adds a lot of excitement to the work that we're doing to support you all for Roman. My science is in low mass galaxies, and I know the low mass galaxy community is also preparing in many ways to think about how to use Roman for our science area. But you know, in addition to the breadth of science for Roman that we're seeing this week and in other communities like exoplanets and in my own home science community, in addition to the breadth of science, we also have a very diverse community in terms of background. You know, we have people that have experience with surveys. We have people that do their primary science through flagship missions like Hubble and Webb, and pretty much everything in between. Roman, of course, is a survey telescope. It's a flagship mission. It's many things. And it touches on those communities, but it's also unique. And so there's a learning curve to know how to use Roman, as there is with any observatory. And depending upon your background, you may need to learn different skills in order to really take full advantage of the observatory. And we all know that while we have amazing science ideas, many of that we've heard about this week, turning science into results is a complex process and requires a lot of hard work. And so today, this morning, we want to get a little pragmatic with you. We want to try to help accelerate the learning curve on how to use Roman. What the data are going to look like, the tools are going to be available, how you might think about crafting a proposal in order to be able to support the process of going from your really cool, compelling science idea to a result. Okay, so that's the goal here today is the, what, where, why, and how with Roman data. The call for proposals right now is scheduled to be released on November 6th, which is only a couple of months away, with proposals due in March. So we're in it. We really are. And while this is going to be a workshop to help accelerate your learning, it doesn't stop here. And I really encourage all of you to make the most of the time between now and the call for proposals and launch to really start understanding and learning how to make the most out of the telescope. So today you're going to hear from a number of different people involved with the development of what you need to do to use Roman data. Our first presentation is going to be from Tom Barclay from the Project Science Office at NASA Goddard down the road. And Tom is going to be introducing the community-defined surveys. So, 75% of Roman's time in the first 5 years will be used for these predefined surveys. And so this will give you a sense of what those observing programs would look like. We'll follow that by a presentation by Patrick Lawrence at IPAC, who's helping lead the development of the Science Support Center. And it's through the Science Support Center at IPAC where you will actually be submitting your proposals for Roman, whether it is to use data from the surveys or to propose for new data. And Patrick is going to walk us through the call for proposals and the actual proposal tool itself that you'll use to submit your proposals. Following that, we're going to have some presentations from folks here at the Science Operations Center at STSCI. Charles Lajoie is going to be talking about the Astronomer's Proposal Tool, or APT, on how you can help visualize any new program that you want to design, and also introducing how to use the Roman exposure time calculator and some of the simulation tools we've created here at the SOC to simulate Roman WFI imaging data and how you might be able to use that simulated imaging data to prepare. We'll also have a live demo of the ETC, of the exposure time calculator, by Yongkun Han. And then we're going to migrate into not how to prepare for the observations, but then how to actually get ready to use the data. So we'll have data products from Roman that are immediately available, and then we'll also be doing data releases. So you're going to hear about the Roman data products and access, including through the Roman Science Platform, which we've named the Roman Research Nexus. And that presentation will be led by Gisela De Rosa, who is running the whole mini workshop today. And then finally, you're actually going to get a live demo of the Nexus by Tyler Desjardins. Finally, when all of that is done, we are also going to have some update from a couple of the project infrastructure teams for Roman. And I know many of you are familiar with the project infrastructure teams or PITs, but for those that might not be as familiar, the PITs are funded community science teams that are tasked with developing specific pipelines and creating specific data products that will help Roman achieve its core science requirement goals around cosmology and exoplanets. And we are privileged to have leaders from 3 of the teams here to give presentations on what their deliverables will be and what their products will be. And you've heard some of them already, some throughout the week already, but we'll have specific presentations from from 3 representatives from project infrastructure teams. So I think it's going to be a really productive morning. Again, this is really focused on accelerating your learning. It is just one part of the journey. The rest of it, we're here to support you through documentation, through future training and webinars, et cetera, et cetera. So this is just one piece of the puzzle, but we're very excited to take advantage of having you all here in person to give you a starter kit. Thank you. And now I'm going to hand it off to Tom Barclay.
Okay, there you go, Tom.
Okay, ready?
You're ready. There you go.
Okay, I can use this. All right, good morning, everyone. Welcome. I think it's going to be an exciting session. And if you haven't seen it already from this week, Roman is happening, and it's happening much, much sooner than many of us are. I don't know, comfortable is the right word, but it's going to happen, which is really, really fantastic. So just as a reminder, I'm sure we all know this, but Roman's going to enable huge scientific strides. Our top science objective is surveys in the infrared. And while we're going to be executing these core community surveys based on the Cadle Survey 2010 priorities, the real purpose of these surveys is not just to meet these objectives, but to enable the broadest science possible. And this week we've heard so far about a lot of that broad science. And as we go through this, I think it's important to remember that as we've worked to define these surveys, thinking about making sure they're broad and enable as much science as possible has been at the forefront of everyone's minds throughout. This process has effectively reached a kind of, not an end point because it's going to be a continuing process, but at least a line in the sand where we've released our report on how we think the plan to execute the core community surveys that came out a few months ago. And I think it's a really good read, especially the primary report that it gives you a really good sense of what Roman is, and it's very exciting. Just as a reminder, as well as what we're talking about here, wide field instrument, Roman's going to enable the next generation of exoplanet discovery through its coronagraph instrument, which will be executing 90 days throughout the first 18 months of the mission. And we're scheduled to start science operations in 2027. Our official launch date for the mission is May 2027, but our team is working towards a launch in October 26, and we're pushing as hard as we can to actually launch in September 2026. So right now, the date that our team is working, really focusing on working towards is September 2026. So I wanted to step back and just kind of mention some of the process. It's important to understand how we got here, and also to really call out the hundreds, potentially even thousands of people working over more than a decade for this survey definition process. Many people in this room, many people who no longer work in science, many people have contributed in enormous, incalculable ways to pushing forward this definition of defining the surveys and working out what we're going to spend the majority of the next 5 years looking at with this NASA's next astrophysics flagship. The way this process started was a large number of people came up with what we call the design reference mission. And so that is a mission, a survey definition of what we're going to do with Roman that meets all the science requirements and essentially demonstrates that we can meet what we plan to do, that the observatory will work. It was always known that this definition wasn't designed to be broad. It was going to change once we brought in more of the science community to enable a broader mission, but it had a singular goal of just proving that we could build an observatory that met our requirements. And so over the last kind of year or two, we've transitioned from the process of having something that just met requirements to having a mission that was what we wanted for the science community. We put together this approach where each of the 3 core community surveys, they're listed at the bottom here, the Wide Area Survey, the Time Domain Survey, and the Galactic Bulge Time Domain Survey. Each of those, and I'll kind of go through in detail a little bit more what each of those surveys is doing, but each of those had a committee of scientists who are engaged in that science, focused on what we could do with that project, both people who've worked in Roman before, but also new people who are engaged in the science but not on the mission yet, brought together into committees to work out what we can do with those surveys. They reviewed over 100 white papers and science pictures that the community submitted, and then over several months came up with a report, and we asked them to submit several versions of what a survey would look like. We named them a nominal, underguide, and overguide. Basically, if we give you a baseline number of days of mission, what does it look like? If we gave you a minimum, what does it look like? And if you gave you a bonus additional time, what would that look like? These surveys were delivered to the high-level committee. This high-level committee had the job of basically working out both which of these surveys and which versions of these surveys fit together, working out if there are conflicts between time. For example, there's certain times of the year that have a lot more competition for time over others. And then really importantly to us, as well as reading these reports from the definition committees, bringing in that background of how do we ensure that time is reserved and appropriate time is reserved for people who want to propose their own surveys, kind of PI or community-defined surveys through other processes. And so we intentionally put on this high-level committee people who are strong advocates of the community who want to propose their own surveys rather than using additional predefined data. So this high-level committee called the ROTAC worked on balancing these things, did a fantastic job, delivered that report a few months ago in April. And I'm not going to mention it too much here, but we went through a process over the last few years to have an additional general astrophysics survey defined early. A committee recommended that early defined survey was a galactic plane survey. That committee is due to report out what the galactic plane survey will look like imminently, I think within weeks. And that'll take about a month of observing time over the first couple of years of Roman operations. So where are we at? I mentioned we solicited these white papers. That was about 2 years ago now. These were reviewed by those committees. In late 2024, the ROTAC convened, and their work of several months reported out. There's numerous presentations. We very, very intentionally wanted to bring the community along with us, and so we had many interim reports and presentations and opportunities for feedback. I would say the community was robust in their feedback to the committee, which was excellent. They certainly, I would say, most people think, people who had something to say gave their feedback, and I think that really actually contributed greatly to improving this. So this process is done, and then the next step of kind of completing this is bringing in these proposals that were touched upon, general astrophysics surveys, which are going to be solicited towards the end of this year. So process is complete. You can go and read the reports on this link, see presentations from the ROTAC committee on what they recommended and what these look like. I'm just going to give a very, very high-level overview, but all the details are in these reports. And the ROTAC report here includes not just their report, but also the lower-level definition committee's reports, which extend many, many more pages and kind of work through how they reviewed the white papers, what things they chose, and also kind of importantly, what white papers they didn't recommend be executed in the surveys, and the reasons why. And in many cases that they've said this is fantastic science, it really uses Roman well. It doesn't fit with the rest of this survey definition, but it would make a great general astrophysics survey and strongly encouraged. So that kind of stuff is worth looking at and understanding. Like I said, the early definition galactic plane survey is wrapping up imminently, and the ROTAC is going to read that report and give us their view on whether that survey should be executed as designed. And I mentioned I wanted to really kind of reinforce that we really wanted this to be a community-defined process. It was really important to us that this was surveys defined by the community for the community. And so this is just a map of people who contributed to the most recent definition process, these reports and the ROTAC and when they exist. This kind of covers almost every continent throughout the world. It really was a broad process. I think went very well overall. Okay, the highest level summary, and as I say, I'll mention what's actually in these surveys in a second, but the higher level summary is the Survey Definition Committee recommended that the High Latitude Wide Area Survey would get its nominal allocation of 520 days. The High Latitude Time Domain Survey also would get its nominal recommendation of 180 days. And then they recommended the overguide version, so the enhanced version of the Galactic Bulge Time Domain survey with some modifications that I can mention. And then really importantly, they also strongly encouraged and recommended a robust general astrophysics survey. So 25.5% of the time, so slightly over the 25% that was kind of mentioned for general astrophysics. I think it would be reserved for general astrophysics surveys, and that includes the galactic plane survey, which is a general astrophysics survey. And that time may increase. The reason being why that may increase is that we hold back a little bit of time for margin. We have a significant calibration program in Roman, and where possible and where there exists kind of time that we can pull back from calibration programs because what isn't needed will be available to general astrophysics. And that will learn as we operate Roman how much calibration time we need and whether we can pare back any of that. Okay, so to kind of touch upon these surveys, the image on the left here shows a really nice image generated by folks here showing where the fields land. Unsurprisingly, this image is dominated by the High Latitude Wide Area Survey, owing to its wide area. But there are dots on here for the other kind of other surveys, and the galactic plane is what was the at the time this figure was made, what the report was looking at recommending is kind of shown there along the galactic plane. So the wide area survey, there's a kind of tiered approach is how they're approaching this. The kind of main thrust of the wide area survey is gravitational, weak lensing, galaxy clustering, BAO, redshift, kind of cosmology work. These observations, because of the nature of covering large amounts of the sky, we spread throughout the 5-year mission, taking imaging and spectroscopy mode. This wide tier would be a single band H-band survey, and then the narrower tiers have imaging and spectroscopy, and then there's a very small ultra deep field here, which is just imaging. Okay. Okay, and this enables all sorts of science. Of course, solar system studies is going to be important to this. One of the areas we're looking at NASA increasing our energy is in planetary defense work, and so I'm pretty excited what this can contribute to planetary defense, but all sorts of high redshift sources in the survey. As I said, I'm running out of time, so I need to move on. But these are kind of the numbers of, and these slides should be available, what was recommended in terms of time, these different fields. But the 600 million galaxy shapes and 19 million galaxies with spectroscopic redshifts is really kind of the headline numbers here. And this kind of shows you the filters in the sky area. The high latitude time domain, as I said, it's a much less area, but a time domain component to this survey. The idea is that there's a cadence of 5 to 10 days. There's fields in the north and south. The expectation is that most of the spectroscopy would be in the south. And the southern fields overlap with the Euclid deep fields. And again, this is looking at primarily, a lot of the work here is supernova, but because of this time domain component, enables a lot of variable sources. Most of this survey will be executed within the middle kind of couple of years of the mission. But as mentioned here, there's several components here. There's the core component in the middle 2 years of the mission with colors and spectroscopy. And we're expecting a pilot survey within the first 6 months or so of the mission, both to explore whether this survey strategy needs to be modified and also to collect data. We encourage all the surveys to come up with a pilot component so that we can kind of have an interim review of how the surveys are going. And finally, the galactic bulge time domain survey. This is probably the survey that had significant modifications. Those of you who remember what the galactic bulge looked like previously, the field placement has changed somewhat significantly here. But the idea is that you point at the galactic bulge, you have a high time cadence. They recommended here a time cadence of about 12 minutes, which is an increase of 15 minutes from the previously defined, the design reference mission version. And while exoplanet microlensing is kind of pushing some of the design choices here, it enables all sorts of science like 100,000 transiting planets. One of the key changes here was adding in a galactic center field, which enables black hole masses and lots of galactic center science. The addition and the enhancement here, I mentioned they're doing the overguide version of the survey. So in the nominal survey, you have 3 seasons, each lasting 70 or so days at the beginning and 3 at the end of the mission. This adds in, and the enhancement here is fields in the middle of the mission as well, but at much, much lower cadence. So the idea is you'd go back and get every few days, every 3 to 5 days, go and get snapshots of these fields. And then you can look at slower varying events that are happening in the middle years. And in addition to that, we're going to collect observation in all the filters, and we're going to do some spectroscopy in these fields. Initially, we were talking to a lot of folks. The idea of doing spectroscopy in crowded fields seemed horrifying, but the more we work through it, the more it seems eminently feasible, not just from a scientific point of view, but from a guiding point of view. We think we can guide with Roman now, which is very exciting. All right, as I mentioned, so the plan is 6 fields, 70.5 days in each of the field times, so six times through over the mission. And then these low cadence fields every 3 to 5 days, and plus these snapshots in spectroscopy mode. What we're working through now, and what folks here are doing fantastic work at the SOC, is to turn this image on the left, which is what we want to look at and where we want to look at things, along with definitions with time, into a survey definition. This is just one realization. It's not meant to represent what we'll actually do in any way, and it's a few months old at this point. But this is looking at, okay, how do we take this and actually fit it into operations? This is being worked through now by the team. We expect to have a report, or I expect to have this baseline finalized within the next couple of months. And then we're going to put all this and make it all available so folks can explore what the surveys look like. And then last point. All right. The last point I wanted to make was we recognize that while these surveys are defined, it's a single point in time, and we haven't launched Roman yet, and we don't know how exactly Roman is going to perform. We just have our estimates. Roman might perform better in some ways, and it might perform worse in others, and our knowledge of the universe might change. And so we're working out right now, how do we have ongoing oversight of these core community surveys? And so we're likely to have something akin to the definition committees that report to the project science team on recommendations for how things, what we should change, how the science kind of landscape is changing, so that if we need to make changes, they can advise us on the impact of those. All right, I better finish because I'm running late, but thank you.
Thank you so much. We're gonna go for 2 quick questions. Anyone?
It's super clear.
Anyone online?
All right.
Questions online?
There you go.
Hi, Tom. Great talk. Your very last point about kind of real-time feedback from the definition, or from some committee on the project, maybe in commissioning or later, and when the mission's ongoing. Can you give a little more detail on what?
Yeah. So this isn't finalized. We're working through it with the committee, the ROTAC chairs. We have a meeting imminently with them to kind of work through it with them. We're gonna. So this isn't baseline. It's more. Right now we're going to write a charter and a plan for how it's going to go, but we recognize that, in your case, the galactic bulge, if we find that we learn new science, or we get the data and we're like, we just don't have the rates we need another field, or we've got loads of rates, but if we could increase the cadence, we could, I don't know. There's all sorts of changes there that, while there's a pretty high bar to make those changes, to be frank, right? People understand what we're doing, expect it. We do recognize that there obviously going to be chances there's going to be changes. If we have higher background than we expect, we may need to look at things. And we want a committee that is made up, both has knowledge from what the core community survey definitions were doing, so legacy from there, but also has kind of a rotating membership of people who can come in, have been using the data, and kind of give us advice and information of what they think we should be doing. But I should really, the ROTAC is what we report is what we're going to go by, and then we aren't going to be making serious changes without, good reasons.
Thank you so much, Tom, again. And if you have more questions, we're going to move on to Patrick Lawrence, who is leading the work at the SSC. Let me find this video. There we go. All good?
Okay. I think
Patrick, you have a timer there.
I do. I need to actually watch that timer, unlike some people. Is that what you're trying to say? I don't know. I don't know what you're trying to hint at, Gisela. Okay, so we just heard about all the core community surveys, and so that's 75% of the time that's already looking at all of the wonderful science you can do. And so what we're going to talk about here is coming up in 5 months is going to be a call for proposals. It's going to be released. And so I wanted to give you kind of an overview, a step through what we've tried to make an easy process to basically submit proposals for both funding to do the investigations and for new observations using Roman. And so I'm working, this is a lot of work that's been done at IPAC through the Science Support Center, and Vivian Yu is the proposal lead currently there. So, okay. So during the operations, the SSC, or the Science Support Center, will issue annual general investigator calls for the science community to submit proposals. This is very similar to what we know with HST, with Spitzer, with JWST. And so this will be where you propose to get funding to conduct the science investigations on the Roman data, the core community surveys, or other new observations that might have been taken. And so that's the majority of it. And then there's also where you can also propose for general astrophysics surveys or new observations. And so as you already heard, some of that new observations have already been sort of set aside for the early release, the Galactic Plane Survey. Most of the science proposals to Roman will be for data analysis support, given the volume and the utility of the data already coming from the core community survey. So we're already anticipating that. Observational research programs will be solicited 3 of those years, 3 of the times during the 5-year prime mission, during cycles 1, this first call, cycles 3, and cycles 4. And there are about 30 programs that we're expecting in total to be able to support these 3 cycles. So we're encouraging people to basically create large teams to collaborate together if you're expecting to create new observations with the actual Roman telescope. The observing modes that we're going to offer in cycle 1 include the WFI imaging and the WFI spectroscopy, because as you know, the CGI is a tech demo. So as Christy already mentioned, in the cycle 1 call will be issued November 6th. And then this is based on a September 2026 launch. So just to keep that in mind. And then proposals will be due on March 5th. All of the information that you need to create your proposal will be coming up in November. We do anticipate proposal preparation workshops to begin to be hosted in the late fall, early winter of 2025. And there is a Roman help desk already up and operational to answer any questions. This is the URL there. And then you can see that there are different areas that you can ask for if you have an actual question on the proposal support or about WFI instrumentation or the observing programs. You can actually just click on there and put in the question that you have. So let's walk through the actual system, what we call the Roman Telescope Proposal System that we built at IPAC, the RTPS. And so this was designed for a single phase submission of all your Roman proposals. And so it allows for multiple resubmissions of proposals and will notify users of a successful submission. You'll get an email back that says you've submitted your proposal. And if you resubmit, it'll say you resubmitted your proposal the 3rd time or the 4th time, or let's say the 50th time, who knows how many times it takes you to write that really good proposal that you want to do. But I'm going to start with the login page. I'm going to, instead of actually giving you kind of an active way to do this, I'm just going to walk through and show you each of the different pages. And so here you'll basically come to an actual login page. And the RTPS system will become active right before the call for proposals. And so this is just a web-based portal that's accessed by a simple login and password. And it also includes the links down there that you can actually find tools, documentation, and links to MAST if you need to will be also there from the data archive as well. So if you want to find more information about any of those things. And so if you don't have a login and password yet to this, because you haven't logged in yet, you can sign up. And if you need to sign up, it's very easy to sign up. It asks for minimum contact information, just your name and institution, email, password, that's it. Just email and password's all you need to be able to log in here. And you can update your password if you forget it. You go back here and basically redo your password. And that's what the email basically sends you back a confirmation. So this is just like any other page that you would be logging into. Okay, once you're in the account, you'll see that you actually have a menu that goes across the top. And this is where I've logged in, obviously. And so you'll have the home bar that takes you back to this page. You have a bar that says new proposal. You have a bar to the right that says my proposals. And then settings that you might want to change your settings. That'll actually take you to the web, your login if you want to change your password, things like that. So if you want to create new proposals, obviously you go to the new proposal web menu, and that takes you to the original proposal submission tool, which we'll go to in a minute. If you've already submitted a proposal, then you want to click on my proposals, and it'll take you to every proposal you've submitted in this cycle. If you submitted proposals for the former cycle, it won't find those. It'll just find the ones for this cycle. Each cycle is brand new. And so you're able to do that. So let's go to new proposal, and this is what you will find in the web page. It's a single stage proposal process, and all of the things that we do are going to be dual anonymous review. And so everything here will be basically just in the database itself. It will not go to the panel review. And so you'll include all the general proposal information that you normally would expect, the type of proposal. You will put in an abstract here, the requested resources for your general investigator proposal, and then your basic team's programmatic information. With this, you can save a draft. You can download it to your website, to your hard drive, sorry. And then you can also submit it. And as I said, you can submit it as many times as you desire to up until the deadline for the proposal. The information here will be saved in a JSON file in your home directory until you submit. And once you submit, it'll actually be saved in our database, as well as you can save it in your home directory to update. If the proposal contains new observations, what you might see here is that grayed out is the box that says summary of observations and the box that says hours. There's a little button up there that says this button contains new observations. And once you click on that, then those will be ungrayed and you'll be able to put in information there. So if you actually contain new observations in your proposal, then you'll actually need to open those up, fill those out, and fill in the summary of observations, which will be sort of an abstract of what you're actually doing technically in your APT file. So the PI information, we're just going down the page. This is the PI info. It's just the first name, last name, email, institution, state, and country, what you would normally expect. And then we've basically made it where you put in the first COI, if you have a COI, which you should, because these are big teams that you're putting together, hopefully. And then you can add or delete COIs as they go along, very similar to the way that you would do if you were, say, adding a paper abstract to a SPE conference or something like that. And so, and then the technical contacts can be selected. The PI will automatically be a technical contact, but then you can designate other COIs as technical contacts or also as co-PIs just by using the buttons right to the right of where you put the COI name. So feel free to ask me any questions as we go page by page, but yes?
Is there an upper limit on the number of co-PIs?
No, there is not. So, and as you see right here, we have two document attachments. There is the PDF, which basically you'll be able to download a template for the proposal to be able to create your scientific justification and your technical justification. If the technical justification should be for observations. If you have the rest of the justification, you'll have a science and a budget justification if you're asking for funding for the actual and general investigations. And then there's a team expertise page, which will basically include information about your team and their expertise in this type of proposal, and you'll be able to drag and drop that PDF. Now, you only have two document attachments if there are no new observations. Yes?
Earlier on the My Proposals tab, you said it lists just your current, your own PI-led proposals?
Yes.
Or both also proposals for your COI?
No, that's true. It's only going to be your PI-led proposals. That's correct.
I think there was another question.
Yeah, I was just wondering whether there's restrictions on institutions for COIs for like European institutions, right?
Not for COIs, no.
Okay.
There will be restrictions for different institutions being able to receive funding, but that'll be done through the grants management. So, okay. And so then if you did actually have new observations that you wanted to propose for, then you would include that in your technical justification part of your scientific part, your justification, sorry. But you would also have now that you've clicked that box that says it needs new observations, not only do you have the hours and the summary observations open up, but now you would have an APT file that you would actually need to complete and drag and drop in there. Now these could be dragged and dropped, or you could actually just click on that box and select it from a directory. The menu will come up to find that. Okay. So expect the Cycle 1 templates to be released with the call for proposals and all of the documentation to be available shortly before the call for proposals go. And so every submission, like I said, will receive a verification email. Down below, you actually have a way to save the JSON file, which will save all the information in the GUI and the links to the PDFs in the APT file. Or you could download a PDF, like say that you actually like the old school way of actually looking at a written PDF, and this is why I put this button in here, is then you can go through and select it all and look at things and mark up the things you want us to see. and then you basically can make the changes yourself, and you don't have to do everything electronic in these days if you don't want to. I know that's old, and so I understand. And then if the final button on the blue button is to be able to submit the proposal, and then you can, that will actually allow you to submit it. And so now we'll get to the question of so then you'll actually have all your current proposals. Let's say I've submitted 3 proposals this cycle. This actually is part of our testing that we've done. You'll actually have a proposal ID on the left-hand side, the title, the type of proposal that you've submitted, when it was last updated, and then you can either edit it and bring it back up into that proposal GUI that we actually have there. You will need to reload attachments because we do expect that the reason you're editing is probably because you're going to be updating that PDF that's going to be part of the scientific justification, not just changing the name, how you spelled your last name. And then you can also download the proposal here as well. We have buttons to download the proposal almost everywhere because that's what I asked for in there. So, but yes, and so that is pretty much the straightforward way that it's going to go. Are there any questions on the GUI? Yes.
The answer to this question may be just wait for the call for proposals.
Sure.
But I'm going to ask it anyway. Am I correct in understanding that there will be sort of 3 broad categories of proposals accepted, that there will be sort of new observations, something that I would think of as like archival, sort of analyze existing observations, and theory?
Yes, that's correct.
And then can you comment on sort of the expected size and scope of funded theory grants?
Not at this moment right now, because we do know, the funding right now is actually kind of, as we all know, is not in the best solid state. So since it's actually inflowing right now, we're not exactly sure of the size of the funding. We will have, by the time the cough comes out, we're defining that right now. We have different tiers for the proposal sizes, small, medium, large, key. And so we're trying to work on exactly what that does mean as far as workforce goes, as far as how much work in the amount of I guess, the amount of detail and work that you would need to put in to be able to produce that. And so then you would decide, where does my proposal fit? And you'd put it in there. And then we would leave it up to the panel review to say, does it actually fit in this category for the amount of science that's going to be produced, or should it go into a different category, maybe a smaller category, or not get selected at all?
So for the small, medium, large, those will qualify. Those will describe theory grants as well, and I'll see a little bit more information on the proposal.
That's correct.
Great, thank you.
Yeah, it's still have, oh, okay. Still have 5 minutes.
I see an urgent DDT category on will there actually be a DDT for Rubin?
Yes, there will be a DDT, but not in the first cycle. And the DDT, or what we're calling discretionary research proposals, will happen in between cycles, or something that's very quick to come up. And so there will be a different, I should have blocked that out, but yes, there's a different button that you would push to that. It would go to a similar proposal page, but very simple, and you'd be able to put that together, submit that, and it would be reviewed almost in a similar manner by scientists and the panels. Yeah. Okay, but you don't get an admin panel. That's only for the administrators. So, just in case you're wondering about that. Okay, so the proposing teams, once the panels meet and the TAC meets, you'll be notified of the final status and given a summary of the TAC comments about 3 months after the deadline, very similar to how you normally propose for ground-based and space-based observing. So all approved programs will be given funding, be given information for the next steps on how to manage the grant funding and how the observations will be planned and scheduled, if there are observations included. So approved programs will receive a new program ID. This is different from your proposal ID. And so you have to remember that those actually kind of now bifurcate. Your proposal ID is no longer anything that has anything to do with the program itself. And programs that contain new observations will be sent to Space Telescope for planning and scheduling using the APT files that you created and you submitted with. The funding cycle is expected to start late 2026 or early fiscal year 2027. So think of it as Q4 in 2026, assuming a September 2026 launch and a contingent upon the availability of funds right now. Okay, any questions about that? I just have this last, just to kind of give you a big view of the timeline that we're looking at right now for cycle 1. We're right here at the Roman Science Conference. Is there an actual pointer? I don't think so.
If you use your cursor, they're gonna see it.
Oh, wow, how cool. Or maybe not. I'm on the wrong, there we go. Ah, okay. So we're right here, the Roman Science Conference. We expect the cycle 1 call to come out November 6th. And then we will have proposal preparation workshops all through this quarter and into, expect it to be at the AAS as well. And February leading up to the cycle 1 deadline in March of 2026. And then cycle 1 selection, and then launch in September, and then commissioning and start of cycle 1 will happen at basically 90 days after launch. Well, commissioning will take the 90 days, and we'll start the cycle 1 right here. Okay. Any questions about that? And if you have any questions about the proposal tool or the selection, feel free to basically go to that help desk and send us a question. We'll be happy to answer any questions that you might have. Yes.
Questions online? Let's start from online.
So will APT files for new observations be done in a phase 1 and phase 2 process as is done for HST?
No, it will not. It'll just be one phase process where you will be submitting that APT file the first time through. And then once you're approved, if the program coordinator here decides that you need some edits or updates to your APT file, you might actually have to do a couple of revisions, but that's normal for an accepted proposal.
So it will be like standard programs or whatever else, like it will be reviewed. You'll be working with an instrument scientist and the PC and do iterative.
Right, but it'll only be one phase before you're actually approved or not. Yes, there was one. Okay, one online.
Yeah, it looks like the proposers can download a full PDF of their proposal. I'm wondering what would be included in the redacted PDF version that the TAC will see. It's given that this is an anonymous review. So the particular, how will the technical details be summarized for the TAC?
So the APT summary is summarized as a target list. And a summary of the observations that you put into APT. So basically a listing of the information on the dither patterns, the filters, and the types of observations along with the target list. But no information on the proposer or the team itself will be given to the TAC.
I think we have 3 questions.
My question was answered, I think, but I guess for clarification, so you're saying that there's an APT file and then there's also this web-based interface. And I'm just wondering, the APT file typically has the capability to upload your proposal information. I was just wondering why the decision was made to have like a separate web-based system in addition to the APT.
The APT is needed because the program and scheduling here actually is able to input and use that for the uplink to the spacecraft, and the Space Telescope is running the operations center. The Science Support Center is actually running the panel reviews, and so we sort of needed to split that out, but the APT was actually still needed. So a lot of that information that a lot of areas where you normally would put in COIs and PIs and abstracts and things like that are going to be grayed out, and you won't be able to see them for the APT that you submit.
Right, thanks.
2 questions. So one is, what can be assumed about the availability of these data products? And then second, like since it's anonymous, like I would also imagine that it would be advantageous that like people in the pit are collaborating with you for your things, right? And so is there a mechanism to convey that, or is that just like you just have whether somebody's in the pit or not cannot be part of the proposal?
I would say number one, I would wait to see what the pits have to say later in this workshop. But two, I don't think we're not going to bar people from the pit proposing to do work with the data. So that will not be a thing. So I would wait to see what the pits are going to do and what they say they're going to produce, and I believe they're serving it through MAST. So.
One last question.
Quick, coming back to that urgent DDT that was on that one. So I was under the impression that maybe it wasn't so feasible for such urgent or maybe time sensitive TOO style of new observing, given how tight the schedule is for all the core surveys. I guess. So I have a question. In APT, I guess so if one is submitting some urgent DDT, APT would tell them the schedulability of it or not within
the other thing is that the discretionary research will have a very high bar that it has to actually meet to be able to break in and be able to meet that. And so that's going to be something that's really goes to the highest levels, and so it wouldn't be just a normal thing. There's a very small percentage of time that would even be used for that. So yeah.
Hey, Tom, do you want to add something?
Yeah. Just to touch, Patrick touched upon this, but to really reinforce it, while for people who are working within the mission, there's a lot of effort to planning observations. For those external, the vast majority of proposals selected and the vast majority of funding support is to support proposals using core community survey data or other general astrophysics survey data, not proposing new surveys. So while certainly there are going to be people in this room proposing surveys, it's going to be fantastic. The vast majority of selections and funding over that is dedicated to survey data because we are a survey mission. And so for those who've worked on things like TESS or Fermi or things like that, that's more similar to the model we're expecting.
Okay, thank you.
Thank you very much. Okay, now we will have Charles Lajoie, who will introduce some of the tools that we're developing here at the SOC, including APT and the ETC. Here we go. Thank you, Charles.
All right.
You also have a timer.
Okay. All right. Sounds good. Good morning, everybody. My name is Charles Philippe Lajoie. I'm a staff scientist and I'm a manager here at the SOC. It's a pleasure to be here this morning to tell you a little bit more about some of the tools, some of the additional tools that we're working on here at the SOC to help you prepare for Roman. So I've taken the liberty of organizing these tools in two groups. The first group being what I call proposal planning tools, which include the astronomer's proposal tool, the APT, as well as the exposure time calculator, the ETC. The other group is what I've called data simulation tools, and that will include STPSF, Roman ISIM, STIPS. And my plan for this quick presentation is to give you a quick teaser, an overview of what these tools can do and when to use it. So it is not a tutorial, it is not a demonstration. That would take a lot more time, but we have a lot of documentation online. The Roman documentation, RDocs, is actually a great reference for all of these tools. So check it out. There's the QR code here. And on there, you'll find examples on how to use the tools, but also installation instructions. So you'll find QR codes and URLs spread out through the presentation. And they all refer to RDocs or some aspects of RDocs. So please check it out. So let's jump right into it. And let's start with the Roman Astronomer's Proposal tool, the APT. Many of you might be familiar with the JWST or the Hubble APT. Roman, being a survey telescope, has a different structure. The observations are organized to survey a large number of targets and or large regions of the sky, or do some time domain observations. So as a result, the Roman APT actually introduces new concepts. For example, we have target regions, we have path plans, and we have survey steps to facilitate you all proposing observation for the Roman Wide Field Instrument. And I'll cover some of these new concepts in the next few slides. And just bear in mind that the Roman APT was developed to support both the core community surveys, which we are implementing here at the SOC, as well as the general astrophysics surveys, which is you all, or some of you. You know, again, refer to that documentation and keep your eyes open for the call for proposals in the next few months, as this will be useful. Okay, so how is the Roman APT different from what you might be used to? One of the new concepts we introduced is that of region or target regions. So while fixed targets are still available, you can import your targets of choice. You can also define targets on regions on the sky by simply inputting the vertices of a polygon, and the region planner will effectively and efficiently fill in that region with what we call segments, these little regions that you see within that region here. And this is actually very useful if you have a large region on the sky you want to cover, or an oddly shaped region. The planner will effectively handle it. And you can also visualize it in Aladdin to make sure that your footprint, your coverage is as expected on top or overlaid on top of a sky image. So these blocks here that you see in the region are what we call segments. They really are the building blocks of a survey in the Roman APT. But you have not yet defined what will happen in those segments. And that is actually done in what we call the path plan. And in the path plan, this is where you'll say, like, I want to do these filters, this prism, the prism, as well as different exposure times, dithers, mosaic. This is really the core of what happens in your observations. And that is done in the path plans. You can have multiple passes that do different things. You can have a few passes that do imaging and other passes that do spectroscopy. In this case, we have both. So you can have multiple passes and that use different things or different targets. So once you have your region, for example, and your path plan, you still don't have an actual survey. The next step is what we call the survey plan, and this is where you're actually going to link all of your passes together. You're going to build, if you will, a sequence of passes on the sky and over time to build your actual survey. And this is where, for example, if you want to have a pass taken, the same pass taken 6 months later or a year later, or if you want the same pass taken at a different orientation on the sky, you're going to specify this with special requirements in the survey plan here. And at the end, you'll have a sequence of passes spread over time and over the sky that will create your overall survey. So as you can see, this is quite different from what you might be used to for Webb or Hubble. So please, I encourage you all to check it out. We have extensive documentation online. Here's the QR code again. The Roman APT user guide is extensive and expansive, and also includes installation instructions if you want to check it out and test it out. I will point out that APT, just like a lot of the tools that I'll be talking about today, is still under development. So we keep enhancing it, we improve it, and we add new features as needed as we go forward. And that is still the case. Okay. The next proposal planning tool that we also offer here at the SOC is the Roman Exposure Time Calculator, the ETC. Many of you might be familiar with the Webb ETC, the JWST ETC. This is more or less the same thing. It's a tool used to get accurate estimates of signal to noise ratios, exposure time, and that kind of numbers. And we offer 3 ways of interfacing or interacting with the ETC. The first and most basic one is through what we call Pangaea. Pangaea is the main engine for the ETC. It's the nuts and bolts of the ETC. And you can directly interface with Pangaea through Python, through programming with Python. And this way of interfacing with ETC is useful if you're interested in searching or exploring a large parameter space, for example, in a programmatic manner. So that's one way to do it. If that's overkill for you, if that's not what you need, we also offer the ETC web interface. And let me show you what this looks like. This should look familiar for some of you. And again, the ETC web interface relies on the Pangaea engine behind the scene, but we offer a graphical user interface that is very easy to use, very friendly to use, to set up essentially the same thing as you would with the Pangaea engine. So you can set up your scenes, your detector or your observing strategy, and you get some nice plots and figures and numbers at the ease of a click on your laptop. So very user friendly. It's another way of using the ETC. And I will note that following this presentation, we'll have a quick live demo by Yun-Kyu Han here about the web interface in particular. Last but not least, we also offer the Roman interactive sensitivity tool, which we call RIST. RIST is also a tool used to get signal-to-noise ratio estimate, but it's a quick look tool, and it's more limited in its use, and that's on purpose. We again use Pangaea in the behind the scene, but in this case we actually have pre-calculated grid of results from Pangaea, and we simply interpolate in that grid for you. So you can see on the left-hand side there's limited inputs that you can provide to it, and it will only return you the signal-to-noise ratio for your setup here. So this is a quick look tool. It's easy to launch, it's quick to run, it's essentially your first stop. If you're unsure whether something is feasible, launch RIST, check it out. If it checks out, or if it doesn't check out, then you may want to investigate further with the web interface and or the Pangaea engine. But that's yet another way of getting some nice signal-to-noise ratio estimates. This is a table just to summarize what I've just covered here for the ETC. There's three ways: Pangaea, the web interface, and RIST. The slides are going to be available. It's also recorded, so check it out. And again, it's all on the RDocs website, so check out our documentation there as well if you need more information. Okay, so that's what I call the proposal planning tools. Now on to the data simulation tools. The data simulation tools could also be thought of helping you prepare and plan for your observations with Roman. But also, these tools are useful to give you an idea of what you might expect out of Roman once it's up and running. And we have a few tools that help you do that. The first one is what we call STPSF. This tool was formerly known as WebPSF, but now that it's been extended to include both Web and Roman, we've changed its name to the Space Telescope Point Spec Function Simulator to be more inclusive. STPSF is a Python package. It's the state-of-the-art package that we have here for simulating point spread function. It will do individual point spread function and includes the latest and greatest information that we have to do so. We received the latest results from the Roman optical model, and that was released just a few weeks ago. And we also have the latest and greatest filter profile and detector pixel scales and so forth. You can see at the bottom here, there's examples, PSF from all the Roman filters, including the GRISM and the PRISM. And I will point out two things. First of all, that STPSF is the underlying PSF simulator for all of our other tools, including Roman ISIM, STIPS, and ETC, which I will cover for the first two there. And also, if the STPSF is an optical simulator and not necessarily a detector simulator. So we don't model the detector artifacts or the instrumental systematics that might be present in actual real WFI data. So something to consider as you use this tool. But if you're interested in understanding and characterizing individual PSF with high accuracy and see how it varies over the field of view of the WFI, STPSF is a great tool to do that. The next tool that we have is called the Roman Image Simulator, or Roman ISIM. Roman sim is actually a scene simulator, allows you to create scenes over all of the WFI detectors. You can have extended and point sources. And it is also a data product, and I'll say a little more about that on this slide later. But essentially, Roman sim uses GalSim to render complex scenes. It uses STPSF for the point spread function simulator. And we also use our calibration reference data system here at the Institute to access the latest and greatest calibration information that we have for WFI. So that in particular allows us to account for noise sources and instrumental systematics such as dark current, re-noise, IPC, and so forth. So the images that you get out of Roman sim are very realistic in that sense. They include a lot of stuff, but also the Roman sim outputs are in the as-diff format as expected by the Roman pipeline. So Roman sim can produce either the level 1, the 3D up the ramp cubes, or go straight to the L2 calibrated ramp fitted images. And either of these you can then take and run into the Roman pipeline to further process to the level 3 and the level 4. So very handy if you want to simulate end-to-end data product calibration, and maybe even test out your own spin on calibration if you're interested in doing that. So here's a collage, if you will, of some Roman sim images over all 18 detectors. You can see there's extended and point sources. There's bad pixels in there. But of course, Roman sim is a simulator. It has its own limitation. We don't include yet everything in it, such as the 1/f noise or the snowballs, reference pixels, and guide windows, the latter of which have different noise properties or may have different noise properties, are not included in there. And I will just reiterate the fact that the reference files that we use for the noise and the instrumental systematics, while they are the latest and greatest, they are still being updated every once in a while as we learn more from the analysis of the ground data. And of course, they will get updated once we're in flight. So if you're interested in high fidelity, pipeline compatible data products, Roman sim is your go-to here. It's a great tool. It does a lot of things. So I encourage you all to check it out and start using it if you need that kind of data. Okay, last but not least, the Space Telescope's Imaging Product Simulator, STIPS for short, is also a scene simulator. You can have extended and point sources, similar to Roman sim. However, STIPS takes a shortcut, if you will. Instead of simulating the up-the-ramp electron accumulation process, STIPS goes straight to a scene. It lays out the scene, and then on top of that, it will add calibration residual. So that has advantages. First of all, it runs faster than Roman sim might. However, one caveat is that you're not getting the 3D cube, the L1 product, as a result. And one other limitation of STIPS is that the outputs are not compatible with the Roman pipeline. So you cannot then use them to further process it with Roman cal. But it's still useful, for example, if you're interested in simulating a lot of data more rapidly than Roman sim might, and then test out your science analysis pipeline or test out what kind of science result you might expect from a large amount of data. So there's a need or there's a use case here for STIPS if that's what you're looking to do here. Quick table here to summarize the differences between our two scene and data product simulator, Roman sim and STIPS. The main differences being that in how the data are simulated in the output formats of these data. And I'm going to end with this slide. It's just a summary of the tools that I've discussed here. I want to encourage everybody to check them out. We have a lot of documentation online with all of these tools. There's examples. And also, while in the near future, when the Roman Research Nexus goes online, you'll also be able to play around with these tools on the platform there. So I'm going to leave this slide up and take any questions if there are any.
Before we go to questions, I want to just say that we understand that APT is going to be new, and in general, creating a scheduling programs for Roman is going to be more complicated. So we are assuming a much more interactive process with instrument scientists at the SOC and the SSC to optimize your surveys and make sure it's schedulable. So we will support that phase. We know that.
There was a
let's go to
question there.
Questions. There you go.
So just a quick question about these past plans for the APT.
Yeah.
So the idea then is these are observations at one point in time. So like say if I wanted to image some patch of the sky, mosaic some patch of the sky in multiple filters, but only at one point in time, right? I don't need different time points throughout the year. That would be a single pass, or you would need to split the filters up into different.
No, as was shown in the screenshot that I had there, you can have multiple filters in one segment. So so effectively all the filters will be, and the prism or grism would be taken back to back in that segment. Yeah.
Thanks.
Yeah. You still have to put that pass in the survey plan though. You still want to quote like put it on the survey. Yeah. So yeah.
More questions? Yeah.
Hi, thanks for the great talk. Do you have plans to like add more modularity to STPS, like simulating detector effects or things like that, or adding extra aberrations beyond what's in the test data?
We do some of that with the web PSS, the web aspect of SCPSF, and we plan on adding some of it for WFI as well. It's still not a full detector simulator as you might wish, but actually in the case of web PSF or the web component of SCPSF, adding, for example, charge diffusion in IPC was the big leap in getting much closer to the observations, and we plan on doing something similar for the WFI. As far as adding additional aberrations, there are ways around to do that. We do expect new results from the optical model in the near future from Goddard as the observatory gets integrated and tested. So there will be update to this, but it's not an easy way to just add additional aberrations there. Yeah.
Yeah, I was actually going to just kind of try to see if I can understand the best way to use these tools, because if we are looking at the majority of proposals are going to be for the core community survey observations, this is the way I kind of see it, would be that I would use maybe the exposure time calculator with the core community survey information to see if I'm going to get the signal to noise for my observation that I want, to be able to get the type of star or the type of galaxy that I want to see. And then I might even actually go and create a Roman ISIM data simulation to basically back that up and put it into my proposal. Does that seem realistic?
Yeah, sounds like.
So we're working on creating workbooks in ETC, the web application, where we're going to implement the service strategy for you at different level of completions, and then you'll be able to put in your source and estimate the signal to noise at various levels. So this is what actually Charles and his team are looking for. And then yes, we're going to also have simulated data sets.
Right.
That simulate a portion of the core community surveys available on the Nexus and available for people to use. So that's the way.
I was just wondering if there's plans to have spectroscopic modes modeled also in a similar way.
Not from the SOC, but maybe Patrick wants to say something about SSC's plans.
There are some of the GRISM and PRISM simulations, but not quite to this ease of use, basically.
I mean, do you want to add something?
Well, we're thinking about combining, for example, the open universe simulations. I mean, that's work that is ongoing. Troxel and Arun and company are working hard on that for PRISM and GRISM. But the main idea is to connect the imaging to the microscopy. But yeah, there's not any firm schedule for that in place. It's just something that we're discussing now.
So this is something, these kind of discussions are at the simulation working group to which is a working group that is open to the community, and we're gonna have multiple QR codes later on. So if you're interested in this kind of discussions, please feel free to sign up for that working. More questions? Yeah.
This may be a repeat for the simulator, the spectroscopic model. But if such type of ETC is available for spectroscopic model, what would you recommend?
So the GRISM and PRISM, they have modes in the ETC, yeah, not in RIST, but in the web interface and Pandia, yeah.
Yeah, so the ETC and Pandia do cover the spectroscopic mode. It's just that Roman ICM is the image simulator,
right,
and
right.
STIX is an image simulator.
Yep.
Can you speak a little bit as to the model you used for the cosmic ray portion of STIPS?
Oh, Tyler, do you know?
For STIPS, I don't recall. I know for Roman ISIM we have a technical report that talks about the cosmic ray model. For STIPS, I don't know if we inherited one, but if you submit that question to the help desk, I think we can follow up with you.
Yeah.
Tyler, STIPS is a fitted ramp, so cosmic rays are irrelevant to STIPS.
Oh, I get it.
Right? I mean,
well,
it's
true.
a scene, right? So there is maybe some
Residuals. Yeah, as I put it there, we add in calibration residuals on top of STIPS. So presumably they would mostly be have been corrected. Yeah.
Questions online? Okay, perfect. Thank you.
Thank you.
Now, Yukio will give us a 10 minutes live demo of the ETC. There you go. How you're going to here.
Hi everyone, I'm Yoon Kyu-han. I'm a staff scientist with Roman team here at the Institute. In this demo, I'm given 10 minutes, so I'll try to do my best to go do the walkthrough, a thorough walkthrough of the web ETC as best as I can. So the web ETC can be accessed at this URL, which is roman.etc.stsc.edu. As we arrive on this landing page, you're going to see 3 panes. That's news, help, and readme. Each contain useful information about the version that the web ETC features. So news contains highlights of the current version of the ETC. The help contains 2 links, one for the video tutorial from JWST ETC, which is very similar to Roman's. And then we have another link for the RDocs home, which will take you to relevant information about the web ETC and the Pandia and RIST as well. This README section will tell you things about the system performance and the accuracy of the ETC. So on top of the page, you'll see 4 buttons. But for the purpose of the demo, I will work as a login user, but you need an account through MySD. So, and it's free to make. So if you don't already have one, you can create using this create user button. But for the demo, I've already logged in myself. And as we log on, this is the page that you'll be ending. This is the page called Available Workbooks, which will show you in all the workbooks that you have an access to that are either owned by you or shared with you by your collaborator. This is the page where you can manage your workbooks by organizing them into folders or share with your collaborator. And for this demo, I've prepared a workbook in advance, and we'll load it. We'll open it by clicking the load button, and I got kicked out. So each session will last for an hour, and I have opened it long before an hour, which is why I'm kicked out. And this is loading. There you go. Clicking the load button will have another separate tab opened in your browser. And this is the workbook that we'll be working throughout the demo. So on top of the workbook, you'll see the workbook ID, which is unique ID that's assigned to your workbook, and then the title of the workbook and the description of the workbook if there's any. Below these 3 boxes, there are 4 tabs: the Calculations tab, Sins and Sources tab, Upload Spectra tab, Caveats and Limitations tabs. Currently, we are on the Calculations tab, where we'll be spending majority of the time during the demo. This tab will tell you will show you the full list of calculations that exist within this workbook. To create a new calculation, you can do so by clicking this instrument drop-down menu, and it will present you whether you want to create an imaging mode or a spectroscopy mode. In this workbook, I've already created 4 calculations, 3 imaging mode and 1 spectroscopy mode. This calculation tab also has additional information like calculation ID, calculation name, the central wavelength of the calculation that was done, the scene number, exposure time, signal to noise ratio, and the calculation status column. We see here that the 2 green check marks next to these imaging and spectroscopy mode indicating that the calculation was successful. So if I click a successful calculation, you'll see that additional informations are populated in the 3 bottom panels: the images pane, plots pane, and the reports pane. In the plots pane, you're going to see extracted flux from the source, extracted flux from the sky background, signal to noise ratio as a function of wavelength, and signal to noise ratio as a function of time. For an imaging mode, you're going to see a single dot at the central wavelength of the filter, but for the spectroscopy mode, you're going to be given the signal to noise ratio as a function of wavelength. In the reports pane, you're going to see the detailed calculation results. And for successful calculations, like these 2 calculations, you're going to be able to download a tar file within this Downloads tab within the reports pane. This contains useful information for you to use for additional offline analysis purposes. Going back to the Calculations tab, we see this orange exclamation mark indicating that saturation has occurred. So saturated pixels can be identified in any of these 4 tabs within the Images pane. The saturated pixel values are removed from the 2D SNR and detector tabs. In the saturation tab, the saturated pixel, if I zoom in, will be marked as red pixel, and then partially saturated pixel will appear as gray, meaning that they saturate before the end of the integration ramp. And within the resultants before saturation tab, you're going to see the fully saturated pixel appear as black. Partially saturated pixels will have lower Z values than the non-saturated pixels, meaning that they only saturate in a few resultants. Additional information are available on those saturated pixels within this Warnings tab that turned red within the Reports pane, and this is going to tell you which pixels and how many pixels are saturated. Going back to the Calculations tab once again, we see this X mark, X red mark, indicating that an error has been made and the calculation was not successful. So unsuccessful calculations do not have any information populated in any of the images or plots pane, but the errors tab in the reports pane has turned red, which will present you a message to help you troubleshoot what the problem was. So in our case, the problem occurred because the source extraction aperture was set to be larger than the inner radius of the background extraction radius. And this error can be modified or updated within using this calculations editor pane on the top of the workbook. So this calculation editor pane has 6 tabs that will let you modify or update the source, scene, and the detector and instrument setup. So the scene tab provides the identical functionality to the scenes and the source, so I'll be covering later. You can also set the sky background given your position, the position of the scene, and use a specific date or the level of the background. You can also set up the filters within the instrument setup. You can choose the detector, one detector out of 18. Within this detector setup, there's also exposure parameters like MA table, and then number of exposures. Please note that the number of resultants drop-down menu will no longer be supported with the web ETC starting the September release. The number of resultants will always be set to max for each MA table. But if you want to explore the number of resultants, you can do so with the Pandaria engine itself. The fifth tab is the strategy tab. This is where we're going to be fixing the problem where we see that the aperture size, the radius was set to 0.5 per arcsecond, whereas the sky annulus was set to 0.4 arcsecond. So if I change this to something smaller than 0.4 and hit calculate, hopefully this fixes the error. There we go. So now we are in a happy place where we fixed the error. And then the last tab is the name tab, where you can change the name of the calculation either here, or if you hover over, you're going to see the pencil icon there. And if you click it, you're going to be able to update the name as you wish. These two will provide the same functionality. The last thing that I wanted to mention for the calculations tabs are these notes section. These are the section where you can record your thought process. Anything you write here will be automatically saved. This could be useful for recording your thought process for certain decisions and certain choices you made for your own future reference, or to be shared with your collaborators. The second major feature is the scenes and the sources. This is the page where you can either create new scene or new source or modify the existing ones. So right now in this workbook, we have 3 scenes and 3 sources. So if I click the scene, the current selection will be turned to yellow along with the corresponding source in that scene marked in green. And bottom here, we see the scene sketch, and we see that our source in the scene is a point source. Please note that this scene sketch is a cartoon to show you the relative size and the position of the source in the scene, and it does not represent the brightness or color of the source. So to change the shape of the source, we can do that by clicking the source in the scene, and we see that there is a shape tab here. So you can either model a point source or extended source. So if you click the extended source, you're going to be presented with a bunch of other options. For the interest of time, I'm not going to go into detail, but you can check the RDocs on what they are to model your extended source. The other thing you can do is to renormalize the source at a specific wavelength or using a specific bandpass. A variety of imaging filters from Rubin, JWST, and HSD are available along with other standard bandpasses. This do not renormalize option should only be used for a user supplied spectra. If you want to use your own spectra in the calculation, you can upload your spectra using this tab. And if you choose file, click choose file, you will be able to load your own spectra. The format of the spectra has to be in either ASCII table with the .dat or .txt file extension, or a FITS table that's in .fits file. It has to have 2 columns, the first column being the wavelength, and then the second column being the flux. And lastly is the caveats and limitations tab, which contains the exact same information that were available in the landing page, but this will tell you details about the ETC, the version of the ETC that the web app is featuring. And then the very last thing that I wanted to mention is that you're going to see throughout the web app these blue question icon, which will take you to the relevant RDocs pages for additional information. And that's it for me.
Questions. So the ETC is available, the web app is available online, and you can start playing with it. Any questions online? Questions in the room? Okay, perfect. So it's 11:02. We're gonna break for 30 minutes. We're at 11:30, and we're gonna talk more about data products and how to access them. Now we're gonna have a presentation on the. See you in Yeah.